Hi everyone! If you have a vacuum tube solar collector, this video will show you how to connect a DIY circulation pump into the system.
You've probably already noticed that if you purchased a version that comes without an integrated water tank, you need to keep circulating the heat transfer fluid at all times, continuously. To keep this fluid moving through the system, you'll need to use a pump. If you don't keep the fluid circulating, the few liters of water inside the collector will basically start to boil in just a few minutes, turn into steam, and as a result, the whole solar collector unit will pretty much be ruined. For the pump, you can use, for example, the same circulation pumps used in cars. Here's one you can see. What's interesting about these car circulation pumps is that they usually come with a 20 millimeter pipe connection, but in plumbing, 20 millimeter pipe diameter is basically unheard of. They use 22 millimeter or 18 millimeter diameters, but I found a solution for how you can still make this work. In underfloor heating systems, you can switch to special fittings, which are used to install 20 millimeter underfloor heating pipes. This is what the nut looks like that's used for the 20 millimeter underfloor heating pipe. So, as I mentioned, while 20 millimeter isn't generally known, it is recognized in the context of 5-layer pipes. The inside of this compression nut is conical, and if you put a rubber washer in it like this, then basically, if you start from this direction, if you start pressing something, the rubber washer will get wedged into the conical part. So it's possible to solve this by carefully placing this conical nut onto, for example, the pump. Let's say we put it onto the discharge fitting like this, then insert the rubber washer in this manner, like this. This part is a 3/4 inch threaded section, while this is a 22 millimeter fitting. By assembling the parts in this specific order, you help ensure that the rubber washer seats properly and forms a good seal, which helps to prevent leaks. This is a solderable part, and it basically fits on just like this. You can screw it together. Let me show you as I screw it together now, and this way it seals perfectly. Once tightened, it doesn't move at all, and it's quite strong. The rubber washer inside gets wedged in securely, which is important because it helps create a tight seal and prevents leaks. This method is commonly used to seal the pump in cars to the subsystem, ensuring a reliable and secure connection. It's also worth considering using something like a check valve in this setup, since a check valve can help prevent backflow and keep the fluid moving in the right direction, which is important for the system to work properly. It's worth installing it on the suction side of the pump. Let me tell you why. Because a pump is not just a pump. If this pump fails for some reason, then the same thing will happen as I mentioned at the beginning of the video. The few liters of water inside the vacuum tube collector will boil, and practically, it depends on what kind of piping was used. But for example, if 5-layer pipes were used, those 5-layer pipes will melt off the solar collector. That's why it's worth setting it up so that we install 2 pumps in parallel. This pump actually looks like this in reality. It consists of a nice large and powerful magnet, an impeller part, and an inner shaft. So in this part of the pump, there are no carbon brushes anywhere at all, which makes it extremely durable and long-lasting. Basically, its durability is almost only affected by the point at which it eventually wears out over time. Either its internal bearing, the sliding bearing part, or this rotor. So this runs here, spins like this, and there's a housing on it. This housing can be seen here. The pump draws in water here and pushes it out here. And if we put 2 of these pumps in parallel, so this would be one and this would be the other, then what would happen is that one pipe comes in, then splits into 2 and connects to the 2 suction ports. Now, if both pumps are running at the same time, everything is fine. Basically, half of the water flow goes through each. Half of the water flow will go to one pump, and the other half to the other pump. However, if one pump breaks down, the problem is that the working pump pushes water out, and then, taking the shortest route, the water flows back through the failed pump and returns. So the water starts circulating in a small loop. This must be prevented, and that's what the check valve is for. So if we install the 2 pumps in parallel, and one of them breaks down, and there is a check valve in the system, it's definitely worth putting one check valve in each branch of the system, because then, basically, the problem is solved. If one pump stops working or fails for any reason, the other pump can't draw water back through the other pump via the path of least resistance, which would otherwise cause issues. Let's take a closer look at what a check valve actually consists of. Inside the check valve, there's a small plastic cap with an axle running through its center. One side of this cap is covered with a rubber coating, and it seals right here, creating a tight closure. So, if the pump starts pushing water from this direction, it lifts this little cap. The water can bypass the cap, and as a result, it basically makes the water flow one way. If one of the pumps breaks down and, say, tries to push water against the cap will press tightly against the metal rim here and seal it. This 12-volt pump is very reliable and will work for many years, 5 to 10 years even. However, when it does break down, that's why it's worth installing two pumps in parallel as a precautionary measure. It's a good idea to put a check valve on the outlet side, which you can basically attach with a coupling and an adapter, making the installation process straightforward. So this will go here, onto the pump's outlet, ensuring proper flow direction. And then you can have another pump in parallel with this one, providing redundancy. If it comes in through one pipe, it goes into the suction side of both pumps. The water comes out of the two outlet sides, then it's connected again. And this is how the coolant will circulate in the solar collector. This applies to flat plate collectors, the ones that don't use vacuum tubes but just have a large metal plate with a coil, as well as those collector solutions where vacuum tubes heat the water. So that's what I wanted to show you. This way you can install it, and if necessary, you can replace the pump. Hi everyone!